A farmer plans to fence a rectangular pasture adjacent to a river. No fencing is required along the side adjacent to the river. The farmer has 1,000 meters of fencing. What dimensions produce the maximum area? So we're going to solve this using calculus techniques, but first let's draw a picture. So we have a river, and along that river we want to build a rectangular pasture. And no fencing is required along the side next to the river. And what we want to do is we want to maximize the area. If we want to maximize the area, we need an equation that represents area. So for area of a rectangle, we're going to let one side represent, let's make this the width and this the length. The area of the rectangle is length times width. Now we want to maximize the area, but at the moment we have too many variables in our equation. We have length and width. And in order to use our calculus techniques, we want to have only one variable. So we're going to use this information about the farmer having 1,000 meters of fencing to be able to reduce the number of variables in the equation. So for this example, the fencing is going to go along these three sides. And because it's a rectangle, I know that this side over here is also the same width as the opposite side. So that 1,000 meters of fencing, we're going to use all of it, and it will equal the length plus 2 times the width. So I can use this is the secondary equation. I can use this secondary equation to solve for one of the variables, either length or width. In this case, I'm going to solve for the length because it doesn't have a coefficient. It'll make my equation a little bit simpler. I'll subtract 2w. That gives me that the length is equal to 1,000 minus 2w. Then I'll be able to substitute this. This is the value of the length. I'll substitute it into my area function. And now my area function goes from having length times width to now having 1,000 minus 2 times the width times the width. I can use the distributive property, and that gives me 1,000 times the width minus 2 times the width squared. So what I've done is I've reduced the number of variables down to just having one variable in my equation. Now I'll be able to use my calculus techniques for finding the maximum value on this area function. I'm going to calculate the derivative of the area function. That's 1,000 minus 4w. I'm going to set this area function equal to 0 to find the critical values. I can add 4w to both sides. That gives me 4w equals 1,000. I'll divide both sides by 4, and that gives me w equals 250. So now I have the critical values. The critical numbers are the possible values of your relative extrema, relative min, or relative max. I'm going to calculate the second derivative so that I can determine if this critical value is a minimum or a maximum. So I have the second derivative, and that is negative 4. And since my second derivative came out to be negative, second derivatives tell you whether you have concave up or concave down. When your second derivative is negative, that's concave down. And that, coupled with 250 being a critical number, means that we have a horizontal tangent line at that value, and we have a maximum at that value. So I know that that value of 250 is a maximum. So we know that we will get a maximum area when the width is 250. I want to go back and read the problem one more time. And the problem says, what dimensions will produce the maximum area? So I also need to know the length. So the length, we had an equation for the length, which is right here. The length is 1,000 minus 2 times the width. 1,000 minus 2 times 250. That's 1,000 minus 500, and that's 500. So the dimensions that will produce the maximum area are a width of 250 and a length of 500, and the units on this are meters. For this problem, we want to solve the problem using calculus techniques, and we're going to show our work on scratch paper for full credit. The fixed monthly cost, F, is calculated to be f of x equals 5,000 in dollars. The variable cost, V, of producing X baseball gloves is V of X equals 0.5x squared minus 80x. The total monthly cost is given as C of X plus C of X, the cost function, is variable cost plus fixed cost. Write a function that represents the total monthly cost. So cost is variable cost plus fixed cost. So our cost function will be 0.5x squared minus 80x plus 5,000. We're just adding those two functions together, the fixed cost and the variable cost. Since none of them had any like terms, that gives us our cost function. We just add those together. In the next part, we want to find out how many baseball gloves must the company sell to minimize the cost. So we're going to use our calculus techniques to find the minimum value. That technique is to calculate the derivative to find the critical values and then test to see if those critical values are minimum or maximum. So we have our cost function. We want to minimize costs. We're going to calculate the derivative of the cost function. So that's the derivative of 0.5x squared. I'll carry down the 0.5. The derivative of x squared is 2x. The derivative of 80x will be 80 minus 80, and the derivative of 5,000 is 0. If I simplify that, derivative of the cost function, 0.5 times 2 is 1. So we get x minus 80. I'll set this function equal to 0 to find my critical value of 80. And then I want to calculate the second derivative of the cost function. I'm taking the derivative of x, which is 1, and the derivative of minus 80 is 0. So since my second derivative came out positive, a positive second derivative is concave up, and concave up tells me that I have a minimum value for this critical number of 80. So 80 is the minimum value. I'm going to need to sell 80 baseball gloves to minimize the cost. And then I can find the minimum cost by substituting into the cost function. I'm going to substitute 80 into 0.5 times 80 squared minus 80 times 80 plus 5,000. And 80 squared is 6,400 minus 6,400. 80 times 80 plus 5,000. Half of 6,400 would be 3,200 minus 6,400 plus 5,000. This gives me 3,200 minus 6,400. That's a negative 3,200 plus 5,000. And that equals, let's see, 5,000 minus 3,200, 1,800. I have a minimum cost of $1,800 when I sell 80 baseball gloves. Thank you for checking out my videos. Have a great day.